Sometimes a question will provide the volume of a solid and ask for the length of an unknown side. When this occurs, set up the volume problem as an algebraic equation, simplify it if possible, and then use inverse operations to find the length of the unknown side. Here's an example. If the volume of a cylinder is 36 pi cubic units and it has a height of 9 units, then its radius is what value? Well, we know that the volume of any cylinder is equal to pi times the radius squared times the height. So we know that the volume is 36 pi cubic units, and we have pi r squared because we don't know the radius, and we put 9 in for the height. If we simplify this or rewrite it, we would have 36 pi is equal to 9 pi times the radius squared. If we divide both sides by 9 pi, the pi's cancel out, and 36 divided by 9 is 4, and we have r squared, or the radius squared, remaining. In order to finish solving this problem, we would need to square root both sides, and whenever you do the inverse operation of square rooting, a plus or minus sign goes in front. So that's why we have positive or negative 2 units would be the radius. However, since the radius cannot be a negative value, its radius must be positive 2 units. Let's try some more problems like this one. The volume of the rectangular prism is 97 2/2 cubic meters. Determine the width of the prism. Well, we know that the volume of the prism is found using the formula length times width times height. You could also write it as area of the base times the height, but then note that the area of the base is length times width. So if we put length and width in for the area of the base, we get length times width times height as the volume formula for a rectangular prism. So we know that the volume is 97 2/2. We know the length is 5.5. The width is our unknown value x, and our height is 6 3/10. So then if we multiply 5.5 and 6 3/10 together, we find that that product is 34 65/100. So 34 65/100 x is equal to 97 2/2. Then if we divide both sides by 34 65/100, we'll get x by itself. And the answer here is 2 8/10. So the width would be 2 8/10 meters long. And here on this slide, it shows the solution, and it follows the same steps that we utilized to solve by plugging in length times width in for area of the base, and then substituting the known values in and solving for the missing variable using division on both sides of the equation. And the width is 2 8/10 meters. The volume of the cylinder is 3,378 14/100 cubic yards. Determine the height of the cylinder. Use 3 14/100 as the value of pi. Well, we know that because we have a cylinder, the volume is calculated using the formula V is equal to B, which represents the area of the base, times the height. But because this is a cylinder, its base is circular. So the area of that base is equal to pi times the radius squared. So let's substitute this expression in for capital B. We would get pi times the radius squared times the height. Now we're told that the volume is 3,378 14/100. So let's substitute that in for V. and that's equal to, we're using 3 14/14 as the value of pi. We know that our radius is 8 2/10 yards, so let's substitute that in. And the height is x in our diagram. So then if we multiply 3 14/14 and 8 2/10 squared, we will get 211 13/100 is equal to 3,378 14/100. And then if we divide both sides by 211 13/100, these cancel out and we're left with x. And when we do that on the left side, we get that the height, or x value, is 16 yards. Now if we go back to that calculator, the reason why it has these extra digits in these later place values is because we've rounded the 211, and instead of writing 1,336 10,000ths, we wrote it as 13/100. So then if you're rounding to the nearest hundredths here, you should do the same with your answer to get a more correct value. And here we can see the solution for this problem, and we did get that the height, or the value of x, is 16 yards.